Hey class, hope everyone's having a wonderful morning. I'm sure you can probably already tell from these photos right here, but today I'm going to be talking about the evolutionary history of Felis Cas domesticus, otherwise known as the domestic cat. Alright, let's move on to some general info. Okay, so starting off here, we have the taxonomy of the domestic cat. By the way, in the context of my presentation, domestic cat, Felis Cas domesticus, they're all synonymous terms, okay? So some facts on its habitat. To start, domestic cats can be found pretty much on a global scale, except for Antarctica. They tend to congregate around human-populated areas, and interestingly enough, even some feral populations can be found around previous human settlements. They prefer to live within temperate regions, which is between the Tropic of Cancer right here, and the Arctic Circle over here, and between the Tropic of Capricorn over down here, and the Antarctic Circle down here. So, what do they eat? As you may have guessed, domestic cats, like a lot of other felines, are typically carnivorous. A healthy diet consists of 30 to 35% muscle meat, 30% carbohydrates, and 8 to 10% fat. By following this diet, they're able to maintain a healthy skin and coat. Some feral species may also hunt stuff like birds and rodents. However, many domestic cats rely on animal feed, which is supplied by humans. And mixed in with those may be some treats such as, everyone knows what this is, cats' favorite treats, temptations. A final point, adult female cats require about 200 to 300 calories per day, while an adult male requires about 250 to 300 calories per day. Okay, in regards to the physical traits of the domestic cat, an interesting fact is that although there are over 100 breeds of domestic cats, most of them share similar physical characteristics. Felis catus has around 244 bones in its body, with 30 of them being vertebrae, although the number does vary depending on body length. Because of this, domestic cats are extremely flexible, some being able to bend half their spine 180 degrees. As you can see in this GIF over here, they can jump up to 5 times their own height, and due to their lack of a collarbone, they're able to slip through narrow cracks in surfaces. Another cool characteristic of Felis catus is its retractable claws, as you can see over here. Domestic cats are able to pull their claws into their paws while walking in order to move stealthily. By keeping their claws in their paws, they are also able to keep them sharp in the case that they must defend themselves. Okay, so here's a final interesting factoid. So Felis catus, usually they have 5 digits on their front limbs and 4 on their hind limbs. However, polydactyly, which is having extra fingers or toes, or in this case, extra digits, isn't too abnormal. As you can see, this cat has a normal paw, and this cat over here has polydactyly. Alright, starting off the list of ancestors, we have Proailurus lemonensis. Here's some context. Around 66 million years ago, an asteroid came down on what is now the Yucatan Peninsula and essentially wiped out the dinosaurs, as you can see in this artistic rendering right here. This ended the Mesozoic period and eventually led to the formation of a power vacuum within the ecosystem, since the dominant dinosaurs had mostly gone extinct. Fossil experts believe that the first feline-like mammal was an animal known as Proailurus, which means first cat. Keeping in mind the brutal competition Proailurus lemonensis had to face, I hypothesized the presence of papillae on the tongue was a variation that would have benefited in the survival of the species. So this is a picture of papillae, and they're basically just tiny projections which can be seen on cats' tongues. They act sort of like filters, helping trap things such as food particles. So papillae on the tongue would have allowed Proailurus lemonensis to scrape the meat off the bones of its prey, enabling it to eat efficiently, leaving little to no energy wasted. Over time, felines that had more rigid grooves on their tongues were probably more fit to survive in their environment, passing down their genes to future generations. Thus, this process would be an example of adaptation and variation. And although modern domestic cats are not usually scraping the meat off their prey, if you look at their tongues nowadays, you can see that they still have them and they actually use them for grooming, which is pretty cool. Okay, so here's the next ancestor, Pseudaiurus transitorius. Another prehistoric cat, Pseudaiurus transitorius, predominantly lived in Europe, Asia, and North America during the Miocene epoch. What's important about this time period is that the Miocene epoch saw a greater increase in global temperatures than its preceding and succeeding periods. This increase in temperature resulted in an increase in the amount of open landscapes, namely deserts, tundras, and grasslands. Here's a picture of a desert and a picture of a tundra right there. And naturally, they aren't copies of what the deserts and tundras looked like 20 million years ago. But what do you notice about these environments? That's right, there's not a lot of cover to hide behind. So imagine this. You're forced into these conditions and have to play a game of tag with your friends. But this is no ordinary game of tag. It's a game that will determine your survival, with the winner living and the loser fading out of existence. With the stakes this high, what trait would you find most valuable? Probably speed. I believe Pseudaiurus transitorius may have been put into a similar situation, and in order to attain greater speeds, some of them look to their claws. So as most of us know, the cheetah is one of the fastest terrestrial mammals in modern days. But what most people don't know is that the secret behind the cheetah's speed is its blunt claws, since they give it traction while it sprints. In a similar vein, I hypothesized that Pseudaiurus transitorius that had blunted claws were able to outpace its prey and hunt down more food, aiding in its survival. This would be an example of a homologous feature, since although Felis catus and Pseudailuris transitorius both have similar bone structures for their claws, the functions could have been different. One with blunted claws for traction and speed, the other sharp, retractable claws for stealth and defense. Common structure, yet differing uses, aids improving evolution over time. Next up, we have Felis challis, also known as the jungle cat. The mating season of jungle cats is characterized by the shrieks and fighting of male cats, and during this time, jungle cats employ a variety of tactics in order to attract suitable partners. For example, they may use intense mew calls, urinate on structures, which serves to both mark territory and advertise themselves to potential mates, or engage in potentially deadly combat. This fierce competition during mating season has ensured that the genes of stronger, more dominant cats have ultimately been passed down to future generations. Thus, this is an example of sexual selection, since the chance of finding a mate and passing on genes is determined, in this case, by how suited a cat is determined to be by the opposite sex through courting behaviors. Couple the selection with the fact that jungle cats are essentially independent at the young age of 8 months, so you can see some infant jungle cats here, and it can be seen that the autonomous nature of domestic cats can be attributed, in part, to the strict selection of mates within a species like the jungle cat. Moving on, we have here Felis nigrips, otherwise known as the black-footed cat. They mainly inhabit dry grasslands, savannas, and deserts in southern Africa. Primarily a nocturnal species, Felis nigrips tend to avoid encounters. In their eyes, they have what is called a plica semilunaris, also known as a nictitating membrane. Essentially a third eyelid, this membrane serves to protect the eyes from things like dust and debris, and it also aids in regulating the admission of light. Right here, this is a picture of a cat with its nictitating membrane showing. While these features would be useful for nocturnal hunters such as Felis nigrips that are living in the dry wild, extra protection from debris and blocking the admission of sunlight is not essential to the survival of a house cat protected by humans. Furthermore, since the domestic cat lacks the muscle fibers to control this nictitating membrane, it can be seen as a vestigial structure which serves to prove its evolution for more nocturnal type hunters over time. The final ancestor I'm going to cover is Felis libica, or the African wildcat. Around 10,000 years ago, humans adopted an agricultural lifestyle within the Fertile Crescent, which is shown in this photo right here. This area in the Middle East was comprised of some modern-day regions such as Syria, Lebanon, and Egypt. With the rise of an agricultural lifestyle, people would have naturally had to deal with pests that tried to steal some of their delicious produce. One of the biggest pests were, as you may have guessed, rodents. Luckily for farmers, wildcats that were willing to cooperate with humans would hunt down these mice, probably just trying to supply themselves with meals. However, over time, farmers would have protected these friendly felines, and these African wildcats would have propagated their genes to future generations. Humans would have artificially selected these cats, favoring and protecting those that hunted down rodents and protected their crops. Thus, the selective pressure was whether or not a cat was willing to cooperate. As humans moved out of the Middle East, they traveled towards Egypt and Asia, bringing what may be one of the earliest forms of the domesticated cat with them. And here's just a gift to illustrate how the African wildcats must have been feeling at the time. I mean, hunting down mice that came to them and having human farmers protect them from other predators? What more could they have asked for? Alright, a quick recap on the evolution of Felis catus domesticus. We had the formation of more rigid papillae on the tongues of Proailurus lemonensis, which would have increased efficiency when it came to eating food, aiding in survival. We had the idea of blunted claws on Pseudailuris transitorius, which would have provided more traction and increased speed for hunting prey in an environment with open landscapes. There was also the competition evident in the mating seasons of the jungle cat, which led to the passing down of genes from stronger, more independent felines. We had the nictitating membrane and how its blockage of debris and light does not serve a huge role in the domestic cat's survival. And finally, we had the artificial selection of Felis libica, the selection pressure being its willingness to cooperate with humans and hunt down rodents. This past March break, I was fortunate enough to get the opportunity to go to Kenya. These are just some photos I took of cats while I was over there. And I have a video right here.
Okay, that's a cute attraction right there.
Do you remember those things called Furbies?
Yon, you're airdropping me those. It's cute. I'm trying to pick them up and take them home with me.
As you can see, the cat here is cleaning itself off using the papillae from its tongue.
Have you guys ever heard of Furbies?
Furbies?
Yeah, my sister has one.
Furbies
Furbies are actually creepy.
I think that's enough. And with that, my presentation is complete. Thank you.